Hi there. Now that you've done some factoring, I wanted to look at some special factorizations. Some of these expressions will factor kind of differently and have a special situation. And so we have three different situations I want to look at. The first one is a very common one. It's called the difference of two squares. And that's going to happen if you have a difference. Obviously, that means subtraction. And then these are going to be perfect squares. So let's look at this first example. I have an x squared minus 9y squared. The first thing I notice is the difference, and then I check, yep, these are two squares. So what really is happening is that middle term that we normally have a trinomial, but that middle term disappeared. And so what happens is the outer and the inner cancel out. And so for this example, in order for that to happen, you set up your two sets of parentheses like normal, and you look at the x squared, and you're going to split that, x and x. And then you have the 9y squared, and you can split that with a 9 and 1 or a 3 and 3. And basically what you're always going to do is you're just going to square root this and split it evenly, and you're going to split this one evenly. So that's going to make this be a 3y and a 3y. Which will always happen that you'll be able to do that because this will always be a perfect square. And then since it's a negative 9, I'll want one of those to be a plus and one of those to be a minus. Now, if you check that's going to be your answer. You're done. But look at what happens when you check your outer and your inner. Or really, let's just do the whole thing. Let's FOIL this back together. So first, multiply to an x squared. Outer, right here, gets me a negative 3xy. Inner gets me a positive 3xy. Do you see how those are going to end up canceling each other out? That always happens. Okay, and then last would get you a negative 9y squared. So you can see there's your x squared minus 9y squared. The middle two terms cancel. That's the way that always works. So the way that you're going to always factor those is to split each one of these evenly like we did, and then you're always going to have one a plus and one a minus because that's always going to be a negative sign there. So let's try this one more time. Now when I look at this one, I see the difference, but what makes me nervous is these are not perfect squares. 3 and 12 are not perfect squares. So you do have to remember that you are always going to be looking to pull out a GCF. So I would pull out a 3 on this one. If I pull out a 3, then I'll have 4x squared minus y squared. And now these are both perfect squares. So I'll leave the 3 out in front. Set up my two binomials. Okay, I'm going to split my 4x squared with a 2x. Split my y squared with a y and a y. One's a plus and one's a minus. And I've got it. That's it. So difference of squares really is a pretty quick and easy type of expression to factor. Let's look at a different one. All right, we have sum and difference of two cubes. Now, the squares business only works if it's a difference, but if it's perfect cubes, you can do a sum or a difference. And by perfect cubes, there's only going to be two terms. This is a plus or maybe a minus, but these are both going to be perfect cubes. All right, so we have a little acronym to help us remember how to factor this, because it does factor kind of weird. And this acronym is common enough, it's starting to appear even in textbooks. So we start off and we have this CR. Okay, this means cube root. So we're going to cube root what we're looking at. And then you're going to cube root again. And I'll show you what I mean in a little bit, but let's go ahead and just write this down. Okay, and this is always going to be a binomial. Then you're going to follow it up with a trinomial. And the trinomial, first thing we'll always reference what's going on over here in the binomial. So this S means square the term. So you look over here and you square this term. Okay, so this is going to mean square. The O means use the opposite sign. So whatever you see right here, we'll do the opposite sign right here. Okay, then P means find the product. The product is the result when you multiply two things together, so we'll be multiplying these two together. The next P means plus. This will always be a plus sign. And then the last one means square it again, which the first time you square this term, the second time you'll square this term. Okay, so let's try a couple. It's really pretty quick and easy once you remember that acronym. So it's going to be a binomial with a trinomial, always. And then I'm going to cube root. So that's going to be a 2x and a 3y. And you will always keep the same sign that is in the problem. So since this is a plus, I'm going to put a plus. Okay, let's go do SOPs. So first thing says square it. So you go to the first term and you're going to square it. So that'll be a 4x squared. And then I do the opposite sign. So that means a minus. Then I'm going to find the product, which means I multiply these two together. So that would get me a 6xy. Now notice the sign isn't right. And that's always going to be the case. It's always going to have the wrong sign. That's why we have that special term there to help us remember what the sign is going to be. Okay, so now I'm ready for this P, so I need to put a plus sign. And then I'm going to square again, but this time I'm going to square the last term. So that'd be a 9y squared. And that trinomial is never going to factor further. You're done. When you factor your perfect cubes there, you just do the binomial, trinomial, you're done. All right, let's try one more. I see it's a minus. Unfortunately, these are not perfect cubes. So, just like last time, remember GCFs, sometimes you can pull something out. So when I look at this and I try to figure out what I can pull out, I think the biggest thing I can pull out is a 2. So if we factor out a 2, this will be a 27x cubed. Hey, that's a perfect cube. Minus 8, yep, there's another perfect cube. All right, so we have the 2, and then we'll have our binomial and our trinomial. So we got a cube root, and keep that sign there. So that'll be a 3x minus 2. Now for our SOPs, or our trinomial, remember we're always referencing over here. So the first one says square it, so I'm going to square this. The O says write the opposite sign, so plus. Find the product of those two, so I'm multiplying these two together, gets me a 6x. Always a plus sign. And then you square it, but this time I'm going to square the last term. So a negative 2 squared is a positive 4. All right, that's it. That's all we got. Okay, the last type of special factorization I'm going to go over, but I really don't feel like a need to memorize this necessarily, because you can factor these just like you factor any trinomial. Now notice they are trinomials this time. We have 3 terms instead of 2 terms. And so you're going to notice here, how you're going to know that it's a perfect square trinomial, is that this first term is going to be a perfect square. Yep. This last term is going to be a perfect square. Yep. And then if I take the square root of my first term, so that would be a 2, and the square root of this term, which would be a 3, so that's a 2 and a 3, that's 6 times 2 is 12, boom, yep, it matches. Okay, but here's the deal. That's fine and dandy, and let's look at what happens when you factor this. The reality is, a lot of times these pop up, and I'm so in tune to factor that I forget that oh wait, that's a special one. Because probably what I'm going to do is say, oh, I don't know, let's split it with a 2x and a 2x. And then factors a 9. I don't know, let's try 3 and 3. It's a positive 9. So I know my signs are the same. So they're both going to need to be minuses. And then I'm going to come back and I'm going to check my outer and my inner. And I get a negative 12x. That's what I want. I've got my answer. I'm done. Okay, so what's really going on though, look at your answer. Do you notice that both binomials are identical? All right, so sometimes you'll even see that written, 2x minus 3, and then they'll square it. That works as well. Again, don't get too caught up in having to memorize this, because you're probably just going to jump in like you would any problem and see if you can factor it, and maybe not get too caught up in the fact that these both have to be the same. Let's practice one more. So again, I see a GCF for sure on this problem. Plus, I don't like to have my first term negative. That always throws me off for factoring. So I'm going to pull out a negative. And I think 3 is going to be the biggest I can go here. So if I pull out a negative 3, this is a 9x squared minus 12xy and a positive 4y squared. I do notice that these are both perfect squares. We'll see if the middle term works out here. So I have my negative 3, set up my factors. Factors of 9, probably going to be 3x and 3x. Factors of 4, I'm going to give a 2 and a 2, or a 2y and a 2y. Okay, since it's a positive 4y, my signs are going to be the same. They're both going to be minuses. All right, now let's check. Outer gets us a negative 6xy. Inner gives us a negative 6xy. That combines to a negative 12xy. All right, I think we're good to go. And you might notice, see how this is the same as that? So you can write it as a quantity squared if you'd like. Okay, that's it for special factorizations. Good luck.